Okay, so we're going to look at another thing that we can do with synthetic division. So I guess actually let's do a second synthetic division example. So let's say we had 4x cubed plus 6x minus 10, and we want to divide that by x minus 2. So we would start a synthetic division. We'd put 4 for x cubed's number. We're missing x squared, so we've got to put 0 as a placeholder for the missing x squared term. 6 is x's number, negative 10 is the constant term. Since I got a minus 2, I put a positive 2 out to the side there. Bring down 4. 2 times 4 is 8. 0 plus 8 is still 8. 2 times 8 is 16. 6 plus 16 is 22. 2 times 22 is 44. Minus 10 is 34. So this is my remainder. This is no x. This is x to the first power. This is x squared. So my answer will be quotient x squared plus 8x plus 22 plus remainder, which is 34, over the divisor, which is x minus 2. So that will be my answer. Okay. So the next thing we're going to do with synthetic division is something called the remainder theorem. So we'll say remainder theorem. What the remainder theorem says is if the polynomial f of x, so if the polynomial f of x is divided by x minus k, then the remainder of that division is equal to the output of the function f when the input is k. So we'll show you how to do one of those to use the remainder theorem real quick. So we'll say for this example, we'll say use the remainder theorem to find f of negative 3 for the function f of x equals negative x to the fourth plus 3x squared minus 4x minus 5. So what I need to do is I need to divide this expression here. So to solve this, I'm going to load in negative 1 is x to the fourth's number, 0 is the missing x cubed, 3 is x squared, negative 4 is x's number, and negative 5 is the constant term. And since I'm trying to find f of negative 3, I put a negative 3 out here. So what I'm dividing by is x minus negative 3 from the remainder theorem. And then what this tells me is when I get done, the number here will be f of negative 3. So I bring down negative 1. Negative 3 times negative 1 is positive 3. This adds up to 3. Negative 3 times 3 is negative 9. This adds up to negative 6. Negative 3 times negative 6 is positive 18. This adds up to 14. We need to do what's 14 times 3. It'll be 3 plus 1 is 4. So this will be negative 42. So negative 3 times 14 is negative 42. This will add up to negative 47. So negative 47, the remainder here, this is what's equal to f of negative 3. So that will be my answer, the negative 47. That's how to use the remainder theorem to evaluate f of negative 3. Okay, so last example that we're going to look at from this section is using the remainder theorem to do one other thing. So for this example, they say decide if k is a 0 of f of x and I'm going to leave a little bit of space here to write some more notes. In part A, they give us the function f of x equals x cubed minus 4x squared plus 9x minus 6, and they tell us k is 1. So leave a little bit of space there for part A. Part B, f of x is equal to x to the fourth plus x squared minus 3x plus 1. They give us a k of negative 1. And then part C, f of x is x to the fourth minus 2x cubed plus 4x squared plus 2x minus 5. And they give us a k which is equal to 1 plus 2i. So, to decide if k is a 0 of f of x, what this really means is they're asking us, is the function f evaluated at k? So whenever I put k as an input into the function, does that equal 0? That's what this is asking us to find, which to figure that out, we can use the synthetic division and just look at the remainder. So basically, to solve each of these, we're going to use the k value they give us. We're going to look at the remainder. If the remainder is 0, so if the remainder ends up being 0, then the k value is a 0. If the remainder is something else, then it's not a 0. So for the first one, we did some, they wanted k equals 1, so we put the 1 out there. We got 0 back as a remainder, so in this case, yes, k equals 1 is a 0 of f. So this next one, they ask us what about k equals negative 1? So we do synthetic division. We have 1 for x to the fourths, 0 for the missing x cubes number, 1 for x squared, negative 3 for x, 1 for the constant term. So we go through and we do synthetic division. Let's see. And we get 6 for a remainder. So in this case, no, k equals negative 1 is not a 0 of f. So we didn't get 0 back for our remainder. This last one we're going to need it's going to work a little differently because we're asking for a complex number. So we're going to put the complex number out there. We're going to need a little bit of scratch work down here. Space your numbers out because with the complex number you need kind of 2 spaces when you go to write stuff out. So we got x to the fourths, x to the thirds, x to the seconds, x to the first, and the constant term. So bring down 1. 1 plus 2i times 1 is 1 plus 2i. Negative 2 plus 1 is negative 1, and 2i plus nothing else is plus 2i. So to get to the next term up here, I need to do 1 plus 2i times negative 1 plus 2i. So I'm going to have to do this as scratch work and write the answer out there. So that'll be negative 1. The outer term will be plus 2i. The inner term will be minus 2i. The last term will be plus 4i squared. So these cancel. 4i squared becomes negative 4. Negative 1 minus 4 is negative 5. So negative 5 goes here. This becomes negative 1. 1 times negative 1 is negative 1. 2i times negative 1 is minus 2i. Add this up. 2 take away 1 is 1. Negative 2i plus nothing is negative 2i. I need to do 1 plus 2i times 1 minus 2i now. So I FOIL that out. 1 times 1 is 1. Outer becomes negative 2i. Inner is positive 2i. Last is negative 4i squared. So these cancel. Negative 4i squared becomes positive 4. 1 plus 4 is positive 5. That adds up to 0. So in this case, yes, k equals 1 plus 2i is a 0 of f. And that will wrap up section 3.2, notes and examples. So we'll stop there.